Hello, Mandela party people. Um, so I'm going to jump into some of the physics of why university students, grad students, and faculty, science fiction enthusiasts, and laymen, news journalists are enjoying the Mandela Effect, right? So, where to begin? Um, so let's see. I'm going to start with 3 semesters of calculus for you in 30 seconds. So Isaac Newton wrote a magic book. The church threatened to kill him, and they forgave him eventually. So this is a curve. That's a curve. It just so happens that when you shoot a cannonball, that's the arc of a cannonball. So, first semester calculus. Is that tangent line to that curve, and with that tangent line you can do all kinds of things. You could figure out the curve, Second semester calculus is the area under the curve, right? Integrals. So you can, depending on how good you are, you can use both those ways to get the curve. Then third semester calculus is three-dimensional curve, volume. So in astronomy, they're plotting the motions of the planets, and there's an unexplained orbit of Mercury, and everyone knew that if you explain that unexplained orbit of Mercury, it's going to revolutionize physics and math, because the orbit of Mercury rosettes. It's not a circular orbit, it's not an oval orbit. It's sort of an oval-like orbit, and then it staggers. So Einstein said the gravity of the sun is causing Mercury to rosette. If you were doing dishes and you let the water go halfway up the sink, fill the sink, and then you let the water go down the drain. The tornado effect, you know, this funnel of water going down the drain is like Mercury going around the sun. So that sounds like a simple explanation, but that's the theory of relativity, right? So people said, well, this is going to have a lot of effects down the road for all kinds of things in physics and everything else, right? So it's forever changed. So one of the things that theory changed is time. So you wake up, you think it's 10:30 a.m., 9:30 a.m., whatever it is. But you already know, if you go down the road and there's from Pacific Standard Time to Mountain Time or Central Time, your time zone is going to change. So people could accept that, right? But they're not going to accept as readily what happens when the theory of relativity gets involved is that as you're moving, time changes. The gravity of the Earth can change time. So they kept an atomic clock. They got 2 atomic clocks, synchronized them. So time is so squarely that if you just have a bunch of atomic clocks, they all have different times, right? So they had 2 atomic clocks. They synchronized them. They kept one on the base of an ordinary B-52 flight line, and they took the other synchronized atomic clock, put it on the B-52, flew it around the world, landed it, and the seconds were, the clocks were 1 second different. So other people have duplicated this, flying just on commercial airlines with atomic clocks. Since then, we have these GPS satellites, and they're all falling out of time with one another all the time. So you have to correct for time dilation, which some people say, oh, that's just time drift. Alright, call it time drift if you want to. You can't cover the holes of this with your finger, it won't work. Alright. So we're getting to the Mandela Effect. You could see, so if you notice, calculus, which was taken from a book of magic, gets you an idea of the natural world, but it doesn't give you everything. So anyway, so then So the theory of relativity, from that point on, time has been really squirrely, and now people have proposed parallel universes. The closest universe is said to be like the Tao Universe, right? So in quantum theory, the electron cloud bonds atoms together, and the electron cloud is used for electronics, communications. When you communicate, it's not the same electron going down the wire to the other end. One electron bumps into the other, the other, and the other, and then a different electron comes out the other end. But in the electron cloud, the electrons go from point A to point B without going in the space in between. That's called quantum tunneling, quantum theory, the uncertainty principle. Those electrons are going to unknown places. It's theorized it's going, into the Tao Universe. Some of the theories say that, right? At least the Tao Universe. So where are these universes? It could be that the matter that we condensed from the previous supernova, all the sister stars. So as soon as we find the sister star to our sun, we're going to find the other portions of matter tied to us. Quantum entanglement. So if you separate two pieces of matter, the electrons communicate instantaneously. Quantum entanglement. So this is leading up to the universe is a computer simulation. Okay, or like a hologram. So what's the projector of our hologram? The sun. So I had a picture and I ran it through Google Deep Dream. The computer dreams, looks at your picture and then prints it out. And I'm going to show you that right now. So here's the picture. Dorothy, she's in Oz, and the reason I picked that is for that saying, Toto, we're not in Kansas anymore. So here, the Google Deep Dream is dreaming this photograph. So here's the Mona Lisa. If you think you know all about the Mona Lisa, the smile and everything, it's a beautiful painting. It turns out that's not the Mona Lisa. This is the real Mona Lisa. It's painted by Leonardo da Vinci. There was an earlier copy. The Mona Lisa in France, hanging in the French Museum, is on a wood panel. The Mona Lisa I showed you before is on canvas. So I think the canvas one is the better copy. So when I showed you the picture and then I put it through Google Deep Dream, so then it should become obvious that if the universe is acting like a computer simulation, you know, if the universe starts to dream, we're going to jump around parallel universes, something like that, right? So I showed you a picture of the Mona Lisa. It's a famous picture. And then when I looked it up on Wikipedia, it was different. So your grasp of what you think is real is not always the case. Mona Lisa is the most famous picture in the world, yet you were fooled between copies of the Mona Lisa. You didn't know, right? So it's the Mandela Effect. There's a movie I recommend seeing. It's called Parallels. And this group is sent to a building, and they start realizing that the building transfers between parallel universes, parallel Earths, right? So the first Earth is the core world, or, you know, like Earth Prime, maybe you would call it Earth Prime, right? And the building keeps taking them through parallel worlds. And I'm going to play a clip from that.
Been empty for years. There's nothing there. Look at all this graffiti of different Earths.
Avoid Earth 33, the contagion has spread.
What is Earth 1?
What the hell is that? Where are we? What's happening?
I take it this is your first trip through the building.
This building jumps every 36 hours.
The building is always the same. Every single universe, everywhere on every Earth, the building is always the same.
You're saying you're from some weird alternate Earth?
How many Earths are there?
Some people think every possible Earth exists.
So as you can see in that clip, building transfers them to parallel worlds. So it's not that those crazy artists are making random movies, and if you think that something from the movie touches your life, that you're crazy. The people that make movies have gone to the university. The bankers have gone to the university. The film producer goes to the bank and says, I'm going to make a movie on parallel universes. And the banker says, oh, that would be enjoyable. Let's do it. Send me tickets. Okay? These movies are from the forefront of science. So I told you, like, there are other mathematics that more accurately describe the universe than calculus. I'm going to get those into another video. These other mathematical systems, more into why the universe can be thought of as a hologram or a computer simulation or a computer program. There's more. There's more to it.